My name's Devyn. I am assistant preserve manager at Pepperwood Preserve, and I've been at Pepperwood since January 2017, so about just a little over 7 years now. Pepperwood is we're a 3,200 acre biological field station. So if you have a research proposal and you're interested, we're absolutely open to folks coming from outside and doing research there. We also have the Dwight Center for Conservation Science, where we have a number of in-house research projects happening. We're a living laboratory, so we're kind of always we have an adaptive management plan, so monitoring our stewardship activities and hoping that our assumptions are correct, and if not, we can modify. So my presentation is just going to cover a little bit about the fire history at Pepperwood, the timing of these fires and the phenology of stinkwort, observations in a post-fire environment from areas that got treated and areas that didn't get treated, and then what happened when a second wildfire came. Pepperwood has burned in 1871, 1923, 1964, 2017, 2019, and then in 2020, we had a wildfire that was just one ridge away. This map on the right-hand side of the screen shows the Henley fire in 64 and the Tubbs fire in 2017. And really what I'm just trying to highlight is we are in a fire corridor. Fire is frequently moving through our area historically. This is a map of Pepperwood and then our two most recent wildfires. The black outline is Pepperwood Preserve boundary, the yellow representing the Tubbs fire, the red representing the 2019 Kincade fire, and that orange is representing the areas where both those wildfires burned. And you can see a large portion of where the two fires overlapped was actually at Pepperwood. Lucky us. Just want to talk about fire. I'm going to kind of dive into some of the challenges we deal with fire, but really want to emphasize there was a lot of ecological benefits that happened from these wildfires. The fires burnt in mosaic. Some areas burnt really hot, some areas burnt moderate, and some were low intensity. And really, it was actually pretty inspiring to see the ecology respond, especially knowing the devastations that our human communities kind of had. Wildflower blooms post-fire. I can't talk about fire and not show the wildflower blooms. The geophytes just loved it. And even areas that burnt pretty hot, like some of our redwood patches, it was just awesome to see how all of these plants kind of responded. So now the real reason we're all here, stinkwort. So this picture is just pulled straight from the CalIPSY website, and it's just, it captures everything that you need to know about the phenology of stinkwort. You have the plant is in full seed, ready to go. There's a flowering and there's budding, all happening at the same time. So the phenology, these plants are just kind of always happening. It's like in a constant flower come late season, which can be a big challenge. So I just selected, honestly, the top 4 fires in recent history that came to my head. This list could have continued to go on and on, as I'm sure we're all aware. So the Tubbs fire was October 2017. The Camp Fire in Paradise area was November 8th. The Kincade fire was October 23rd. The August complex was started in August, but it went through November. And really what I'm trying to highlight here is that these late fall wildflowers are becoming more and more common. As our fire season expands, due to climate issues, due to fuels issues, we're seeing these wildflowers run late into the fall. And what does that mean for stinkwort? Pulled off of the CalFlora website, just seeing the bloom period of stinkwort, September, October, November, and thinking about that phenology picture. When it's in bloom, it's probably also seeding. So those seeding time periods are lining up perfectly with these late fall wildflowers. This is pretty unique for annual plants, as somebody mentioned in a previous one. And then even just comparing it to yellow star thistle, which is a later flowering species as well, stinkwort is even later than that. So it's really filling this interesting late fall niche of phenology. So keep that in mind as we move forward. So this is a map of our identified stinkwort populations on the preserve prior to the 2017 fire. The orange dots are indicating populations of stinkwort that we had identified and were treating. And really what stands out to me about this is, as it's been mentioned over and over again today, all of our populations are associated with our road system. So you can see those brown lines and gray lines and black lines are our road network through the reserve. And every single one of our stinkwort population was directly associated with a road. This is our mapped populations of stinkwort fall 2018, so about a year after the Tubbs fire. There is a lot of new populations not associated with the roads anymore. How is that possible? So this is something that we've learned from in conversations with our state park partners, our regional park partners, other land managers. They started to notice populations of stinkwort popping up in areas that are not frequently traveled. Populations hadn't been seen before, and there didn't seem to be a clear vector other than they started showing up after the wildfire. So just looking in the kind of top right corner where those green dots are, that's a wonderful example of an area. We don't graze over there. No human access really happens other than maybe a few preserve staff hiking out there. The only reason we stumbled across those plants was surveying for invasive plants and surveying for damage post-fire. So just thinking about what that vector is to spread them. During the Tubbs fire, we had 70-mile-an-hour winds. CAL FIRE was finding spot fires that night of the fire about 2 miles ahead from the flaming front of the fire. So if you're thinking about ember cast being able to move 2 miles, and then you think of that little Detrichia seed that is hanging out on the plant, ready to kind of go with those high winds, also in these large wildfires, you're getting a big convection columns that are happening from the intensity of the heat of these wildfires. So it's lifting particulate material, probably seeds, up into the air. And then when the smoke settles, it's landing on bare ground, right? Because you have this wildfire disturbance come through, seeds are potentially lifted, cast into the air, and then coming and landing on nutrient-rich, recently burnt soil. So having that disturbance and the seed distribution happening with these late fall wildfires. All right, so some observations of treatment and no treatment. I'm going to start with no treatment first. This is kind of a little drawing I did of year 1, 2, and 3 post-fire. Black is representing bare burnt ground. Yellow is representing our stinkwort populations or individual plants. And green is representing the naturalized or native vegetation coming back in the post-fire. So immediately after the fire, we saw this random dispersal of stinkwort plants. There didn't seem to be any dense populations. It was like one over here, walk another 100 feet, you see one over there. And so if you imagine the dispersal from wildfire and all these seeds kind of sprinkling around and landing, you would imagine they wouldn't probably land in dense populations. So we kind of got this random dispersal. Year 2, we started to see a lot of naturalized and native vegetation come back. And this really, I think Miranda's research, I felt very validated when I heard it. We started to see this competition coming back, and the stinkwort didn't compete well with it. However, some areas burnt really hot in the scar of a tree. There wasn't vegetation coming back. And so we would see the stinkwort populations actually start to congregate into these hot burn areas where the naturalized native vegetation haven't started to recover in that area. So you started to see a smaller or denser patches, but less of them. And they kind of started to get pushed into these circles. Year 3, even less areas of bare ground. So those patches still got dense, but there was less and less of them. Year 4, you can kind of imagine the same thing happens. And eventually they're potentially going to be outcompeted by annual grasses and native vegetation, which might be a good thing. However, those seeds have been setting. So your seed bank is getting established. So this is a picture of in year 3 of kind of just what we were seeing. So you can see there's bare ground. It looks like there was a manzanita there. So that was a patch of ground that burnt really hot. And then you can see the stinkwort hanging out just in the area where that soil is disturbed. You moved out into that annual grass. That's not even native vegetation. That's just, it looks like maybe avena, probably some Italian ryegrass, annual grasses. The tricky is not really competing with that. So in areas we treated, we mainly went through and hand pulled large dispersals of area, random populations. It was easier for us to just go and hand pull and bag. When we find larger populations, we would use aster specific transline. We found it worked pretty well with just one treatment. And we actually saw a really awesome success when we would just go and hand pull those individual plants or treat those individual plants. So as we all know, early detection, rapid response does work. And then with the issues with all these wildfires, you're dealing with infrastructure loss. It was the first time our organization went through a wildfire. So there's, our community lost so much. So there were so many of these other factors. We unfortunately weren't able to get out and really survey and get all these populations. Hence, we had no treatment area. That wasn't by choice. So we mainly prioritize around waterways, road systems, and sensitive ecological resources, really thinking we were going to reduce those vectors of spread, mainly being our road system. So then impacts from the second wildfire. Just a map to remind you of kind of in that bottom left corner is kind of the area I'm going to be focusing on. And I actually think that's exactly where Rachel's picture was, showing some stinkwort coming up in a post fire in her earlier slides. So those 3 little dots kind of in the bottom, the green yellow dots in the bottom left-hand corner, we did not get to treat. We didn't get out there, pretty remote area, a little rugged, not much access. So we didn't treat that. Burnt in that second wildfire, and like I said, that seed bank already existed, right? Even though those populations were getting smaller and smaller, this is what that area looked like after that second wildfire. So we saw that random dispersal. Again, we saw really those same patterns we saw in the Tubbs fire. However, in areas we did not treat, there was a large explosion of stinkwort that kind of happened. So this was fall 2019. So this is first year post the second wildfire. However, we started to see that same pattern again. Native vegetation would start to come in and those numbers would reduce. However, now there's a larger seed bank. So that next disturbance comes through. We're in a fire prone area. So we are prepared for a wildfire, basically potentially any summer. Also, prescribed fire, thinking of management treatments that might also create disturbance. So now, even though they kind of disappear of time as you move away from that wildfire, that seed bank still exists. So just a huge shout out to all of our wonderful volunteers that really helped us pull those plants, a number of organizations that really helped us with our post-fire recovery, and we're big support in our community. Thank you all.
Any questions on Zoom? Any questions in the room?
Did you, Devyn, did you see also evidence of stinkwort being brought in by equipment after the fire?
So after the 2017 fire, there was no real response. It was like we kind of got hit in the first couple of days of that fire. So there wasn't suppression efforts made at Pepperwood during the 17 fire. However, during the 19 fire, there was bulldozers that stopped the fire on our property. And actually we surveyed those lines very extensively and did not see any stinkwort in those dozer lines. Other non-natives, but stinkwort wasn't one of them, which is interesting. Doesn't mean it can't happen, but I didn't notice any.
Any other questions?
Devyn, you mentioned prescribed fire and thinking about our stinkwort populations ahead of those types of treatments. Obviously, we're not doing those when it's super windy, so we don't think they'll carry, but are you worried about, is your primary concern sort of weeds blowing into that fresh soil? Or what are the things that you're thinking about with those treatments?
Yeah. So when I mentioned that, I was actually mainly thinking of after the seeds had spread from the wildfire, that now we have a seed bank already established. And then when you burn them, they might pop back up. Seed viability, how long? I'm really interested in finding that out. So I don't know what the answer is to like mitigate that other than, hey, after you do a prescribed fire, walk the land, check it out. And so just be ready, especially if you burn in a wildfire, who knows what seeds blew in at that time. So important to survey post fire disturbance, whether that be wildfire or prescribed fire.
Go ahead, Serena.
From Zoom, how about fire killing seeds?
I mean, as we saw from that second wildfire, I don't think, I mean, if you have dense fuel built up and you have something burning hot, like say a pile or like a tree that is burning for a long period of time, when you have high residency time, yeah, I think that can kill the seed bank. But on just a landscape scale, seeing that impact from the second wildfire, I would think not. No.
We have time for more questions if there are any.
We built in lots of question time.
Hi, what a great presentation. I'm curious, have you ever tested in any of your sites, or did you have any plot to go seed deliberately after fire, to seed with a seed mix with natives, but who knows what else?
Yeah, not an experimental level, but we've done a number of seeding and grass plug planting of native perennial grasses in post fire areas. And seeding, we see some success with our grass plugs. We see a lot of success. It does require the whole nursery back end of everything. But yeah.
So did you see some improvement, like, less invasion, like, or because, when you seed perennial seeds, most of the times you have to wait until they establish, right? Annuals catch up faster. So I was wondering
In
maybe,
areas
so
in areas we seeded, I don't know if I saw less competition, other than maybe slightly quicker revegetation in areas. And I think we really focused our seeding and plugging areas in those really hot burnt areas. So, some of the areas that maybe wouldn't get that naturalized or native establishment immediately. So a trunk of a tree that kind of burnt, and we'd throw some seeds down and kind of plug into those hot burn areas. And we see really good success doing that in pile burn scars. So areas that do burn really hot and do kill the seed bank, I think that's a really good opportunity to try and establish native seeds in those areas.